Let us now take the second model from number series, where we are going to discuss questions based on AP, GP and HP. That is nothing but arithmetic, geometric and harmonic progressions. Let us look at some examples here. Now, the example 1 here is 9, 16, 23, 30, 37 question mark. So we are supposed to find out what comes in place of question mark. As I've already mentioned, it is all about understanding the logic behind the given series. That is to understand what is the rhythm behind these numbers to find out the missing number. So let us now observe the series and try to understand what is the logic behind the given numbers. Now, as you can see, the numbers are 9, 16, 23, 30, 37 and question mark. If you try to observe the difference between two consecutive numbers, we find that 9 and 16, that means 9 plus 7 gives 16. Then 16 plus 7 will be equal to 23. 23 plus 7 is 30 and 30 plus 7 will be equal to 37. That means very clearly the difference between two consecutive numbers here is equal to 7. So we can say that the next number here, which comes in place of question mark, should be 37 plus 7. That is nothing but 37 plus 7, and 37 plus 7 will be equal to 44. So that will be the missing number for the given series. So here we find that the difference between two consecutive terms is always 7, and such a series is called as arithmetic series. So arithmetic series is nothing but where the difference between any two consecutive terms is a fixed value, as 7 in the given case. So once we understand that this is the logic there, we can simply find out the missing number as 37 plus 7, that is equal to 44. Let us now look at the next example, that is 67, 58, 49, 41, 31, 22. And here we are supposed to find out which of the given numbers is wrong. It is not about finding out a missing number, but instead we need to find out of these given numbers which is the wrong number, or which is the number which does not fit in this series. Again, here also we need to identify the logic behind the given numbers. Now this is actually a decreasing series. The numbers are decreasing gradually. Like in the previous case, the numbers were increasing gradually. Here we have the numbers which decreases one after the other. Again, let us try to observe the difference between these numbers. As I've mentioned, there is no particular rule or method to get the answer, but we're just trying to understand the logic by checking the differences between two consecutive numbers. Now when we look at 67 and 58, we understand that 67 minus 9 is equal to 58. That means 67 minus 9 will be giving the next number 58. Again, 58 minus 9 is 49. 58 minus 9 is 49. So by looking at the first two differences, we feel that maybe the difference here is always minus 9. The difference between two consecutive terms here may be minus 9. But when we proceed, we find that 49 minus 9 should give us 40. But the given number here is 41. So maybe 41 here is the wrong number. But simply here itself we cannot say that 41 is wrong. We also need to confirm that by looking at the various other numbers. So assuming that minus 9 is the pattern here, or minus 9 is the logic here, let us continue and see if 31 and 22 are the right numbers with respect to 40 or not. Now if we take 40 as the correct number in place of 41, then again going forward we'll have 40 minus 9, that is equal to 31. And 31 minus 9 again will give us 22. So here we find that the difference between two consecutive terms is always minus 9 except in case of 41. So 41 is the wrong number. 41 will not fit in this series. Instead, we should have 40 as the correct number there. So we can say that the wrong number here is 41. Even in this case, you find that the difference between two consecutive terms is constant. So this is also a case of arithmetic series, where the difference between two consecutive terms is a constant value. So from these two examples, it is clear that questions may be given either in terms of missing number or in terms of finding out the wrong number. In both the cases, we need to identify the logic behind the given series and find out the missing number or the wrong number as per the given question. We also observe in these two examples that the series is either gradually increasing or gradually decreasing, and both are arithmetic series cases. So whenever you find that a series is increasing gradually or decreasing gradually, just try to understand the difference between two consecutive numbers. If the difference comes out to be a fixed value, then it is definitely an arithmetic series case, and accordingly we can either find out the missing number or the wrong number. Let us now take the next set of examples from model 2 of number series, where the series are based on geometric progressions. That is nothing but the ratio between two consecutive terms of the given series is a constant value. Let us look at some examples and understand this. The first example here we have is 14, 70, 350, question mark, 8750 and 43750. So as you can see here, we need to find out what comes in place of the question mark. Now if we try to observe the numbers here, they are increasing sharply. Like in the previous case of arithmetic series, the numbers were increasing gradually. But here we find that the numbers increase exponentially, or I can say they increase sharply. That is, there is a sudden jump in the numbers. Like 14 becomes 70, 70 becomes 350. Then we have 8750 and this becomes 43750. So there may be a chance that the ratio between two consecutive terms is a common value or it is a constant value. So let's understand what is the ratio between two consecutive terms of the given series. Or that is nothing but if each number when multiplied with a fixed value gives us the succeeding number. For example, 14 into 5 will give us 70. So we can say that 14 when multiplied with 5 gives the second term 70. Likewise, 70 when multiplied with 5 gives the third term 350. So there is a chance that into 5 is a common ratio, or nothing but when each term is multiplied with 5, it gives us the next term. So according to that, the question mark here should be nothing but 350 into 5. That is again multiplied by 5 should give us the value of question mark. So this should be equal to 350 into 5. And 350 into 5 will be equal to 1750. But again, as I've mentioned earlier, here itself we cannot say that 1750 is the answer. If this 1750 justifies the remaining two numbers as per the multiplication with 5, then only we can say that it is a correct answer. Otherwise, we may have to look for some other logic behind the given series. So let's see whether 1750 into 5 gives us the next term or not. Now 1750 into 5 will be equal to 8750. 1750 into 5 is equal to 8750. And similarly, 8750 into 5 will be equal to 43750. That is 43,750. So very clearly, the ratio between two consecutive terms here is common. Or we can say that when each term multiplied with 5 gives us the next term. By the term ratio, we mean that 70 by 14 is 5. 350 by 70 is 5. Similarly, 1750 by 350 is 5. So we can either say that the ratio is common or each term is multiplied by a fixed value to get the next term. Such a series is called a geometric series. So whenever friends you find that a series is increasing sharply, you just try to observe if there is a common ratio between two consecutive terms. And if you're able to identify that, it will be easy for us to find out the missing number. And as I've already mentioned, if you are not able to get this idea within 30 or 45 seconds, it is better that you leave it and go for the next question. Why? Because there is no guarantee that we'll be getting answers for number series questions, as logics are infinitely many. So we just have to go for a trial and error method for 30-45 seconds for questions like number series. And if you practice more on these type of questions, there are fair chances that you will get the right answers in the right time. Let us now take another example here. 8,000, 1,600, 320, 64. And what will be the next term? Again, here we have to find out the missing term. Now if you observe, even this series is similar to example number 3. That is, here also when each term multiplied by a common value gives us the next term. But the point to be observed here is, here it is not an integer that we are multiplying to the term, but in fact it is a decimal value. For example, 8,000 into 0.2 will give us 1,600. Or that is nothing but 8,000 into 1 by 5. 8,000 divided by 5 is equal to 1,600. Similarly, 1,600 into 0.2 will be equal to 320. 320 into 0.2 will be equal to 64. So here we can say that the next term can be obtained when 64 is multiplied with 0.2. Why? Because so far we have observed that each term when multiplied by 0.2 gives us the next term. So that has to be the logic behind the given series. So 64 into 0.2 is equal to 12.8. So we can say that the question mark here will be equal to 12.8. So as you can see, either we can take it as into 0.2 for all the terms, or it can be taken as into 1 by 5. Or you can also understand it as divided by 5. Each term when divided by 5 gives us the next term. For example, 8,000 divided by 5 is 1,600. 1,600 divided by 5 is 320. 320 divided by 5 is 64. So 64 divided by 5 will be equal to 12.8. So these are the questions which are based on geometric series, where the multiplication factor between two consecutive terms is always a fixed value. So by enough practice, we should be able to understand that the given series is in terms of a geometric progression, and we should be able to find out the missing number or the wrong number. Here again, the questions may be given in terms of finding out the wrong number. So we again have to find out the logic in terms of geometric progression and identify the wrong number out of the given series. Let us now take the next example from model 2 of number series. And here the given question is based on harmonic progression. We know that harmonic progression is the one where the reciprocal of the given series are in a particular pattern. Let's take an example to understand that. Now the question here is 1 by 3, 1 by 7, 1 by 11, question mark, 1 by 19 and 1 by 23. And we're supposed to find out what comes in place of question mark. If you try to take the reciprocal of the given series, that means the inverse of the given values. 1 by 3 here is 3, 1 by 7 reciprocal is 7, 1 by 11 inverse is 11. And question mark has to be calculated. Then 1 by 19 gives us 19 and 1 by 23 gives 23 as the inverse. That means here if you try to observe the inverse of the given series or the reciprocal of each of the terms of the given series, we find that the difference between two consecutive terms is a common value or it is a fixed value. For example, 3 plus 4 is 7, 7 plus 4 is 11. And likewise 19 plus 4 is 23. So now we can understand that the difference between two terms here seems to be a constant value, that is nothing but 4. So if we try to take 11 plus 4, we should get what comes in place of question mark. We know that 11 plus 4 is 15. And if we try to cross verify, 15 plus 4 again gives us 19. That means in the complete series we find that the difference between two consecutive terms is always 4. So with that we can say that 15 should be the one which comes in place of question mark in the inverse series. Now if 15 comes in place of question mark, when we take the reciprocal, what comes in the original series should be 1 by 15. So that is our answer. That is 1 by 3, 1 by 7, 1 by 11, 1 by 15, 1 by 19 and 1 by 23. Such a series is called harmonic progression, where the difference between the reciprocal of the given numbers is a fixed value. So friends, from the various examples that we have taken in model number 2, we have seen that the given series may be an arithmetic series or a geometric series or a harmonic series. It is just that we need to feel the rhythm of the series and identify what is the logic behind that. If you are able to do that successfully in 30 seconds, then we'll get the right answers. Otherwise, there's no other option but to leave the question. And from these various examples of model 2, we can understand that it's all about understanding the relationship between two consecutive terms of the given series to identify the logic. So practice well on these type of questions and make sure that next time when a series is given in terms of arithmetic, geometric or harmonic progression, you don't miss out on it and quickly get the right answer by understanding the proper logic behind that.